Good morning, everybody, and today we're going to be working on something called mutually exclusive events. We're going to work on mutually exclusive events, and what are they? Well, we'll discover that in just a few moments. All right, so let's look at the first example. It says set A has 15 items, set B has 20 items. 5 items are part of both sets, and the total in both sets are 30 items. All right, so I'm starting with this because Venn diagrams are familiar to us. We've just worked with them. Simple subtraction offers 15 minus 5 is 10, and 20 minus 5 is 15. And that's it. We're not going to deal with anything that's outside the circles. Okay, 10 and 15 is 25, plus 5 is 30. 10 plus 5 plus 15 gives you all 30, and we're done there. All right, how about sets C and D? Set C has 25 items, and set D has 10 items. I guess that's it. But the major difference is that circles C and D don't have any overlap. There's nothing common in C that is also in D and vice versa. Whereas in sets A and B, they do have a 5 number overlap. 5 people are in both circles A and B. All right, so A intersected with B is 5. A unified with B. Remember, union means everything. So A union B is the 10 plus the 5 plus the 15, which is 30. Union means everything. C unified with D happens to be 35. And C intersected with D, well, is there any intersection here? Is there anything that they share in common? The answer is no. So C intersected with D here is just 0. So, by definition, two events are mutually exclusive if they look like circles C and D, where they share nothing in common. All right, and how we write that is they cannot occur together at the same time. At the same time. And therefore, there's no common outcomes, or no intersection. All right. And so it says draw a red card from a deck of cards. Event B is draw a club from a deck of cards. The probability that a card is both a red card and a club. For those not familiar with cards, pause this video right now and please get out your reference sheet. Okay, now that you have your reference sheet out, red cards are diamonds and hearts. They are the diamonds and the hearts. Clubs and spades are the black cards in a deck of cards. So can a card be both red and a club, a black club at the same time? The answer is no. So what's the chances of both of those events occurring at the same time, being red and a club? 0. That's being mutually exclusive. Those two events are mutually exclusive of one another. The probability that a card drawn is a red card or a club. Well, let's think about the probabilities of each. To be red is half the deck, so that's 26 cards out of 52. And then a club is one of the suits, so that's 13 cards, another 13 cards out of 52. And now comes the more important word of the day, the most important word of the day, or. If we have 26 red and we have 13 clubs and I'm closing my eyes and I could choose any one of them, I'm simply going to add up all these cards. The word or, when you're dealing with a probability of drawing one card or one event, one thing, is equal to addition. All right, so 26 plus 13 is 39 out of 52. And that reduces to 3/4. Or means add. All right, down to definitions right now. If two events are mutually exclusive, then the probability of A or B occurring, let's simply look right here. It's the probability that A will occur plus the probability that B will occur. The title of today's lesson is the addition rule, or tells you to add. If two events are not mutually exclusive, We'll get to that definition in just a second. Okay, we'll get to that definition in just a second. But before we get to that definition, let's do some examples right here. Find the probabilities when rolling 2 dice. Okay, once again, have your 2 dice chart handy. The probability of rolling a 7. If you look at the diagonal in your 2 dice chart where the 7s are, there are 6 of them. So that'd be 6 possibilities out of 36, which reduces to 1/6. Sorry, this keeps popping up there. Let me go scroll down there. All right, here, I'll pop that for right now. What's the probability that the sum equals 11? Take a look. There are 2 11s on your chart out of 36 numbers, so that's 1 out of 18. The sum is a 7, or the sum is 11, or tells you to add. So I'm going to take the 6 out of 36 possibilities plus the 2 possibilities of rolling 11. If I roll 2 dice, can I roll a sum of 7 and a sum of 11 at the same time? The answer is no, I can't. So then I just add these up and I get 8 out of 36, which reduces to 2/9. Last but not least, what about rolling a sum of 7 and a sum of 11? Can we do both at the same time? Again, we just asked that question, and the answer is no can do. It's impossible to roll a sum of 7 and a sum of 11 at the same time. So these two events are mutually exclusive, and the chances that both can happen at the same time is 0. That's it. All right, pause the video, replay it if you need more time looking at it. We're going on to number 2. Now we're looking at our reference sheet at the card distribution. What's the chances that a card could be both a red or a queen? All right, so we've looked at our card distribution, and there's 26 cards out of 52 that are red. Or means add. There are also 4 queens in the deck. Now this is the turning point in the lesson. Should I just add 26 plus 4 and get 30 out of 52 and call it a day? The answer is no. Why not? Because didn't we count some cards as part of both groups? Are there some red queens, in other words? There are. There's the queen of diamonds, and there's the queen of hearts. They are both queens, and they're both red cards. So we counted them in the first group, and we counted them in the second group. I like those red queens, but I don't like them twice as much. So we need to subtract away the 2, we need to subtract away the 2 cards that we counted twice, the 2 red queens. And so 26 plus 4 minus 2 is 28 out of 52, which reduces to 7 over 13. Apologize, that keeps popping up every time I press another part of my finger. What's the chances that a card is a red and a queen? Well, how many red queens are there? We just found that out. Those are these 2 out of 52 right here. Uh-oh. There we go. Those are these 2 red queens right here. So my answer for part B is just the 2 out of 52 that they share together, 1 out of 26. A black king, or a club. Okay, so how many black kings are in a deck of cards? There's the king of clubs, and there's the king of spades. All right, and then, or a club. So there's 2 black kings, 2 out of 52. Or means plus. Or always tells you to add. How many clubs are in a deck of cards? So there are 13 clubs in a deck of cards. Have your card distribution out. Are there any kings of clubs? Because black are these 2 cards and clubs. Yeah, here's the king of clubs right there. So I need to subtract away anything I counted twice. Well, I counted the king of clubs in the first, and I counted the king of clubs in the second, so I'm going to subtract away the 1 king of clubs that I counted twice. The only king of clubs. So 2 plus 13 is 17, minus 1 is 16 out of 52. And that reduces to, let's see here. Oh wait, 2 plus 13, yeah, it's 15. 15 minus 1 is 14. Sorry guys, I can't count today. 14 out of 52. And that reduces to 7 over 26. I'm going to stop the video now because I can only go 10 minutes.